So people have been asking me occasionally about this question: how do I write a polynomial function when they gave me certain roots? Well, so question number 15 is one of the ones that you were assigned out of this textbook, out of that Demana textbook. So what we're going to do is we're going to start out. I noticed they told me that x equals 2 is one of the zeros. Well, that means one of the factors is going to be x minus 2. Because if we just think about you solving it for 0 to get this, solve instead equals 0 to solve for x, so we'll just move it backwards. And then they're telling me it's a multiplicity 2. So that means that function acts like x squared when x equals 2. So it touches the x-axis at x equals 2. And then they're telling me this complex 0 is a 0. And it has multiplicity 1. So how do you deal with that? Well, one thing you need to remember is that when I have a complex 0, that's coming from I had a square root of a negative number. And complex zeros always occur in conjugate pairs. So if x equals 3 plus I is a 0, that also means that x equals 3 minus I is a 0. So how do I do, so similar to what I did here, I want to set that equal to 0, but the I really makes things a little more difficult. So what I'm going to do is this: I'm going to subtract 3 from both sides. I'm going to leave that I alone. In fact, I'm going to do the same thing for this other factor, just so you see this. And then I got the I because I took a square root of a negative number. So what I'm going to do is I'm going to square both sides of this equation. Well, when I square x minus 3, please don't write x squared plus 9. Remember, you're gonna write a polynomial, write a binomial twice, and then FOIL it. And then, of course, I squared is negative 1. So this is going to give me x squared minus 6x plus 9, which equals negative 1. So that tells me x squared minus 6x plus 10 is one of the zeros. What about this other 0? What if I square both sides here? Well, the left-hand side looks exactly the same. What is negative I squared? What if I treat it like that? Well, when I square a negative, it's positive, and I squared is negative 1. So do you see how I get exactly the same polynomial? X squared minus 6x plus 9, it's exactly the same. So I only really have to, for this kind of math, I only have to worry about one of those complex roots. I don't have to worry about the other one. So that's how I deal with the complex roots. And so what do I have? I know f of x equals x minus 1 squared times this x squared minus 6x plus 10. Now, if they want me, if I can leave it in factored form, I'm all done. That's all I need to do. However, if you're going to do this on Math Excel, they like it factored out, at least in this one exercise that somebody asked me about. So I've got to do some, here, you know what I'm going to do this natively in Paint. So I've got to expand the x minus 1. So remember, x minus 1 squared is x minus 1 times x minus 1. That gives me x squared and then minus 2x plus 1. And then so that leaves me x squared minus 2x plus 1 times x squared minus 6x plus 10. So now I just have to do all this distributing. So I've got x to the 4th minus 6x to the 3rd minus 10x squared. Then I'm going to distribute the negative 2x through. That leaves me negative 2x to the 3rd plus 12x squared minus 20x. And then I got to distribute. Here, let me get fancy and change my color here. Then I'm going to distribute that positive 1 through. And of course, that doesn't change anything. So let's see here. That leaves me x squared. Notice the way I'm lining up. Hopefully you remember this from earlier work. Notice the way I'm lining up the like terms when I do the three multiplications. So this first one is just multiplying the x squared through. This next one is distributing the negative 2x through. And this last one is distributing a 1 through. And then I just combine all my like terms. Minus 8x cubed plus, oh, let's see, I almost made that mistake, plus 3x. I was going to write 2x. Because 1x squared plus 12x squared is 13x squared. Minus 10 would make it 3x squared minus 26x plus 10. And that is the expanded form of that polynomial. And that's how you do that kind of problem. Hopefully it helps.